Yes, now I am going to talk about the derivation of expression for the acceptance angle and also the condition for light propagation in the optical fiber. So I have shown here the diagram of the longitudinal cross section of the optical fiber. So this is the cladding region, this is the core region. So here is the light ray which is passing along this path, that is AO. It is from the outer medium. The light ray is incident into the optical fiber through the length AO. Once it enters the core medium, it will go along this path OB and it will be incident at the core cladding boundary here. And here, let us say the angle becomes equal to exactly the critical angle. Then the light ray will just graze along the boundary separating the core and cladding. So this is what we have taken. So the angle of incidence here in the outer medium, we have taken it as theta naught. So that theta naught is called as the acceptance angle, for which this is the how the light ray will pass. Now let us apply the mathematical part for this. So we will make use of this Snell's law. So apply this Snell's law of refraction at the point O. So you can write it as n naught. N naught is the refractive index of the outer medium into the sine of the angle, that is theta naught. N naught sine theta naught becomes equal to n1 sine theta 1. n1 is the refractive index of the core medium and theta 1 is the angle here. So therefore you can write n1 sine theta 1. So n naught sine theta naught is equal to n1 sine theta 1. Call it equation 1. The same way we can apply this Snell's law of refraction at another point here, at point B, where the light ray is going from core to cladding medium. So here the angle of incidence becomes equal to critical angle theta c and angle of refraction becomes equal to 90 degree. So therefore we can write n1 sin theta c is equal to n2 sin 90 degree, and sin 90 degree is 1, and theta c can be written from this diagram here. This is the right angle triangle. So from theta c we can write theta c is equal to 90 minus theta 1. Therefore substituting in this equation we can write it as n1 sin of 90 minus theta 1 is equal to n2, or n1 cos theta 1 is equal to n2, or therefore cos theta 1 is equal to n2 by n1, and therefore sin theta 1 is square root of 1 minus cos square theta 1. We can write cos square theta 1 from this, that is n2 square by n1 square. So now substituting in equation 1, that is equation 1 says n naught sin theta naught is equal to n1 sin theta 1. So sin theta 1 we can substitute from this here. So you get n naught sin theta 1 naught equals n1 square root of n1 square minus n2 square divided by n1, that is equal to this, or sin theta naught therefore is given by square root of n1 square minus n2 square by n naught. So we get here therefore the expression for the theta naught or sin theta naught as this. For light ray to undergo total internal reflection within the optical fiber, the angle of incidence from the outer medium must be less than this theta naught. So therefore I write theta I, the angle of incidence must be less than theta naught. Therefore theta I must be less than theta naught, which is given by sine inverse of root of n1 square minus n2 square divided by n naught.